Hi everyone, this is Bidirectional and today we're going to simulate another project. And today's project is a bidirectional counter room lighting system control together with temperature monitoring, right? So I would like to start with explaining the components that I've used to make this project, and later on we're gonna see the code a little bit, and we'll be back to look on how it works, right? As I said, in this project I've designed a bidirectional counter. So for the bidirectional counter I've used infrared sensors, the IR sensors. As you see here, I've got this one here, IR1 is the first infrared sensor, and this IR1 I've used it to count the number of people that are entering the room, right? And I've got another infrared sensor which is IR2, and I've used it to count the number of people that are leaving the room, right? So to get the number of people inside the room, we're going to just subtract the two numbers, the people that are entering the room, and subtract it from the number of people that are leaving the room, and we're gonna know the number of people that are inside the room, right? Okay, I'm not going to explain how each component works. Okay, I've got another for the room temperature control. I've got this LM35 temperature sensor, and to control the temperature of the room I've used this motor here to represent the cooling fan, right? So for the lighting system, we got, let's say you have a room, maybe a classroom with maybe 3 or 4, or it can be more than that, rows of lamps. Most of the classes, they do have a row of fluorescent lamps. So to make sure that we do not consume much power or electrical energy, it's better to have this kind of a system where according to the number of people inside the room, we're going to switch a certain number of rows of lamps instead of switching all the lamps together, right? That's the advantage of using this system, right? To simulate IR sensor, I've connected it with a logic state device, so to the tester pen. So if I change it to logic 1, there will be a high output signal to the microcontroller. The same for the second IR sensor, and inside the code I've just written that whenever the output of this sensor to the microcontroller is high, we're gonna increase a number that to indicate that there is an obstacle detected, and that's how it really works, right? So we're going to count every single part of this logic state to represent that a person maybe is entering or leaving the room, right? And I've got 3 lamps here. The first one here is it will be representing the first row of fluorescent lamps, and the second row, and also the third row, right? The LCD will be displaying maybe the number of people that are leaving the room, number of people that are entering the room, and also the number of people that are inside the room, right? Okay, so before I show you how this system works, let me explain a little bit about the code, right? This is my code. It's a simple one. The first line is just a library file for the liquid crystal display. I've got 2 IR1 and IR2, the 2 infrared sensors. I've connected to pin number 3 and the pin number 4. Okay, I've got 3 lamps as you saw. The first one is connected to pin number 5, then the pin number 2 and pin number 6. I've got a fan which is connected to pin number 7, and also define the pin for LM35, which is A0. Okay, I've got some variables here. It's in temperature equal to 0. This variable will be used to store the temperature readings of the LM35, and I've got two Boolean variables. I have val1 to store the status of the infrared sensors, and I have three variables for my counting things. Okay, I got the variable to install the number of people that are inside the room, the number of people that are entering the room, also the number of people that are leaving the room, right? And I've just created an object file for the liquid crystal display and specify the pins that are connected it, right? Inside the setup function, it's just started by initializing the object LCD and specify the size of the LCD. Okay, using pin mode, I've just configured my pins, right? For the infrared, 2 IRs, those are the input devices, and if you go down here, we're gonna see about the lamp 1, lamp 2, and lamp 3. These are the output together with the fan. About the LM35, so the temperature sensor, so it is an input device, right? I usually do write the digital output devices to logic low before starting doing anything inside the loop function, right? Inside the loop function, the best thing that I do recommend for any programmer, usually I prefer to start with reading the input signals. So as you see here, I'm just reading, as you see here in these 3 lines over here. The first one is just reading the first IR sensor, and the second one is just reading the second IR sensor, and here is just reading the samples from LM35 and convert them to temperature readings. Okay, as we know, this 500 over 10.3 comes from the specification of the LM35 itself, which is 1 millivolts per. Okay, so we're gonna say if you do convert it, you get something from that. I'm not going. If you have any question about this conversion, feel free to ask. I will try to give you some tip, right? So for 1 new centigrade, this is the most used LM35 specification. Well, okay, and then I've just this is just a display, and the LCD just set cursor to 0,0 and then print the workroom light control. Okay, this one, I'll be printing the people that are inside, the people that are leaving the room, and people inside the room, right? Okay, I've called here the 2 functions here, temperature function and also counting function. After calling these 2 functions, you see here, this is the very important line, that the people inside the room is equal to the people that are entering the room minus the people that are leaving the room, right? So if people inside the room is equal to 1, so let's say there is a single person inside the room, we're going to switch a single light, right, or a single lamp or a row of lamps. Okay, and else if people inside the room is greater than 2 and people inside the room is less than 5, so it will take a range from 2 to 4. If the number of people again is from 2 to 4, we are going to switch only a single row of lamps, and else if the people inside the room is equal to 5, now we're going to allow 2 rows of lamps to be on. Okay, here I've just set another range of number of people. If number of people is greater than or equal to 5 and it's below 10, it means from 5 to 9 people inside the room, we're going to switch only 2 rows of lamps. And then if the number of people is greater than or equal to 10, we're going to switch all rows of the lamp, else we're going to turn all the lamps off, right? So the most interesting part is the counting part. How do I count the number of people that are entering and leaving the room? This is the function here. If I val, this is the variable which stores the states of the infrared sensor. If it goes high, I'm going to delay a little bit, because sometimes when the infrared sensor detects an obstacle, the output pin stays high for maybe it might take a second. In the process, if you try to simulate it, it might take a second. So if you didn't put a delay here, you can get multiple numbers. So to avoid that, just put a delay and scan again. If it's still high, then increment the number of people that are entering the room. The same for the number of people that are leaving the room. So using this delay, you're going to get the most accurate counting using the infrared sensors. Is that right? Okay. For the temperature sensor, it's too easy. If the temperature reading is above or equal to 30, we're going to turn on the fan, and also else if it's below 30 now, okay, we are going to turn it off, right? This is a simple code for this simulation. Now let's see how it works. Let me start the simulation over here. Wow, now it's cool. As we see here, the room light control, the number of people inside the room that are entering the room is 0. The number of people that are leaving the room is 0 again. If the number of people inside the room is 0, right? Okay, the cooling fan is off, and all rows of lamps are off, right? So as I said, this first infrared sensor is used to count the number of people that are entering the room. So if we enable this logic state over here, as I said, there is some the output of the infrared sensor will stay high for some milliseconds. So okay, for that delay, okay, now you see the number of people that are entering the room changes to 1. From the code, we say that okay, if the number of people is equal to 1 inside the room, we're going to switch only a single row of lamps. So now you see there the first row of lamp is on, and the rest of the rows are still off. So let us increase a little bit of numbers of people. So here we go, the second one. We have to wait a little bit. Okay. Okay, let me add up to maybe 5. Okay, the second one is already there. The third person. Okay, is there again the fourth person. Then I'm going to put another value there. Wow. Okay. Now, okay, there are 5 people inside the room. So from the code, we saw that if the number of people inside the room is 5, Then we're going to switch 2 rows at a time, right? So you see here the second row and the first row are on. So what we're gonna do here, let's say somebody has left the room. Okay, we're gonna put single value there, so that people leaving the room will be the people out will be 1, right? Okay, so people inside the room is 4 now. Okay, if the 2 from the code we have written condition that if the number is between 2 and 4, it's 2 to 4, I mean 2, 3 and 4, we are going to stick with first row, right? If another person enter here, okay, now the people inside that are entering will be 6 and the people out is 1, so the people inside will be 5 right here. So what are we gonna have here is that, okay, the second row has to go on because the number of people now inside the room is 5. Let us go to maybe 10 people inside the room. I will add up the number. That is 6. Wow, now we got 7. Okay, I'm gonna try. Let me just make it work by itself. Okay, it's okay, let me remove it. Gonna get 8. Gonna get 7 again, 7. So 8 minus 1. Okay, we're gonna get 9. Oh, it's 8 again. Wow, 9, right? Okay, let's enter another person there. It's the people n will be 10. Also, people inside the room will be 9. We're gonna add another 1 there. Okay, it's 9 now. Yeah, here we go. We got people. It will be 11 now. So 11 minus 1, we get 10. Oh, okay. So we need to see all 3 rows of lines go on, right? Okay, there we go. The people inside the room now is 10. So all 3 rows are on, as you see here. We have done with the, if somebody left the room, let's say, okay, somebody left the room, so people out will be 2 and people inside will be 9. So the third row has to go off by itself, right? Okay, this will be 2. There we go. Oh, it's 9, not 9. It's 9. This 0 is just a garbage. Just ignore it, right? We have done with the counting and thus bidirectional counting, and see how we can control the room lighting system by using this bidirectional counting. So let us move to another part, which is the temperature control. As we said, as you see here, the temperature reading is about 27, right? So if we try to increase it to maybe above, okay, it's 30 or above 30, the cooling fan is on, will be on like that. Okay, so as to make the room more comfortable. Okay, if it falls below, maybe below 30, something like 28, something like that, the fan will stop, okay, running. So thank you guys. Just subscribe to my channel for more project simulation like this. Later on I'll try to show you the real prototype. Thank you guys for watching the video. I hope you like it. Just keep subscribing to my channel. See you on the next video.